So previously we have solved this question. Now let me tell you another way by which you can solve this question. The first part remains the same. That is, first of all, we have to show these two triangles to be congruent. Now once you have shown these two triangles to be congruent, what are the corresponding sides? See, we know BC is equal to BC, BE is equal to FC. So what remains? BF, that is BF is equal to EC. So from here we get BF is equal to EC. I repeat, BE is equal to CF given to us. BC is the common side. So what is the third pair of corresponding sides? BF and EC. You can get from here as well. BF is equal to EC. So this implies BF is equal to EC. What is the reason? CPCT, corresponding parts of congruent triangles. Right? Now in the next step, what we're going to do is we're going to take another pair of triangles. This time I'm going to take triangle AEB. So this triangle over here, triangle AEB and triangle AFC. So slightly difficult to visualize, triangle AEB and triangle AFC. So just try to follow. In triangle AEB and triangle AFC. So in these two triangles, what do I know? The first thing I know is, see, if this is 90, this is also 90, this is also 90. So this angle is equal to this angle, right? That is, both of them are 90. So what is this angle? Angle AEB. Angle AEB is equal to this angle, angle AFC. Why? Both of them are 90 degrees. Next step, angle A is a common angle. I repeat, in both the triangles, A is a common angle. So I'll say angle A is equal to angle A. What is the reason? Common angle. So this over here is given to us. Basically the angles are 90. Angle A is equal to angle A, common angle. So in two triangles, if two corresponding angles are equal, we need one side to be equal. What is that side? B and CF. So BE is equal to CF. So we have, I'll continue it over here. That is BE is equal to CF. This again is given to us. So which criteria have we used? Angle, angle, side. So just to avoid confusion. So by Aas criteria, the two triangles are congruent. I repeat, look at these two triangles, AEB and AFC. See, these two angles are 90, A is a common angle and B is equal to CF. So by angle side criteria, the two triangles are congruent. So this implies triangle ABE, so AEB is congruent to triangle AEB is congruent to triangle AFC. Let's verify. See, angle A is equal to angle A. Correct. BE should be equal to CF. B is equal to CF. And angle AEB, that is angle E is equal to angle F. Correct. What is the criteria we've used? Angle side. So now once you show these two triangles to be congruent, what do we get from here? From here what we get is AF is equal to AE. See, AE, first two letters is equal to AF. So from here we get AE is equal to AF. What is the reason? From CPCT, corresponding parts of congruent triangles. So now, what do we got? So what did we get earlier? We got BF is equal to EC. Take this and take this together. So let me first drop this off. Remember, BF is equal to EC and AF is equal to AE. So just add these two, we'll get AB is equal to AC. I'll just show you. So let me first drop this off. What I'm going to keep is that BF is equal to EC, we got over here, and B and A is equal to EF, we just got it over here. So let me rub this off and let me show you how to prove AB is equal to AC. So first of all, we showed these two triangles to be congruent. From there we got BF is equal to EC. Then we just showed these two triangles to be congruent. We got AF is equal to AE. So let's say I call this 1 and this I call 2. So now see, BF is equal to EC and AF is equal to AE. So if I add these two and if I add these two, I'll get AB is equal to AC. So what do? Simply add these two. So adding 1 and 2. So how do we add two equations? Left hand side plus left hand side. So left hand side of equation 1 BF plus left hand side of equation 2 AF is equal to right hand side plus right hand side. That is EC plus AE. So what is BF plus AF? BF plus AF is AB is equal to EC plus AE, that is AC. So we get AB is equal to AC. The moment you get AB is equal to AC, that means the triangle is isosceles. So this implies triangle ABC is isosceles. This is what we had to prove. Two sides are equal. We have shown. So this is another way by which you can prove the triangle is isosceles. This is slightly more complicated, right? That is, we have to again prove a pair of triangles to be congruent. But nevertheless, if it does not strike you, that is, if you forget the theorem, in a triangle, if two angles are equal, then opposite sides are equal, you can use this way. So I repeat, first prove these two triangles to be congruent, you'll get BF is equal to EC. Then prove the above two triangles to be congruent. I repeat, triangle AEB and triangle AFC. You'll get AF is equal to AE. Then all you have to do is simply add these two equations, you'll get AB is equal to AC, right? So this is another way by which you can solve this question.